Hello dear students, this is Dr. Sourav Sir's class. We are now solving some question from statistics. So this question is telling us that which of the following is a valid cumulative distribution function. Option 1 is telling us that fx equals to 1 by 2 plus x square if our x is less than 0 and 2 plus x square by 3 plus x square if our x is positive or 0, that means x is not non-negative. When now option 2 is telling us that fx is equals to 1 by 2 plus x square if our x is negative and 2 plus x square by 3 plus 2x square if our x is non-negative, and the similar options are all. Okay, so what can be done? So now we are trying to determine which of the given functions is a valid cumulative distribution function. So we need to check if the following conditions are satisfied. So what are the conditions for it? So the non-decreasing property, because our we know that our fx should be non-decreasing, non-decreasing across all x. Okay, so now the second point is range of the values, that means the fx should be in range 0 1. Fx should be in range closed 0 1. And the third point is what? The third point tells us that the limits, that means my limit extends to minus infinity of fx and limit extends to infinity fx, there has to be, this is 0 and this is 1. So let me analyze this function step by step. So now the symbolic computation encountered complexities with the trigonometric function and the piecewise definitions. Instead, I will analyze the problem step by step manually. So to verify a valid CDF, I need to check this. Okay, yeah. So our option 1 is this. Let me rewrite it. Fx equals to, there will be 1 by 2 plus x square if our x is less than 0 and 2 plus x square by 3 plus x square if our x is greater than equals to 0. So now at x less than 0, my fx is approaching to 0. That means, no, sorry, fx, as our x tends to minus infinity, our fx is approaching to 0. Now we can see that at x greater than equals to 0, our fx will be then 2 plus x square by 3 plus x square. So at x tends to infinity, this will approach 1, and we can easily see that our fx is in between this and our, yeah, our fx is non-decreasing. We can again say that non-decreasing. So our option 1 is a correct option of this question. So now we have to think about our option 2. So what can be done for that? Let me, yeah. So now we are checking about our option 2. We can only have to check about one thing, because our this part will go to 0 and we have to check only this part. Okay. So fx is equals to my 2 plus x square by 3 plus 2x square. Then what will happen? Limit x tends to infinity, 2 plus x square by 3 plus 2x square. We can do that. Limit x tends to infinity, 2 by x square plus 1 by 3 by x square plus 2. So then that will be 0 and that will be 0. So we will get half. So this is not equals to 1. So our option 2 will not be a CDF. So our option 2 will be cancelled. So now we have to think about our option 3. Our option 3. So the first part of option 3 is also can be determined. Yeah, because this will go to 0. So now we have to think about this case. Okay. So yeah. So our fx equals to 2 cos x plus x square by that is my 4 plus x square. So our at x tends to infinity, our cos x will oscillate. So then we cannot have any particular limit. So we can so they are violating the monotonicity. So our option C will be cancelled out. So now we have to think about our option 4. Yeah, I think that will be a correct option. But again, I have to think about our this part, because this part will again go to 0. Okay. So f of x is equals to my 1 plus x square by 4 plus x square. Then what will happen? Then limit x tends to infinity, 1 plus x square by 4 plus x square. Then it will be my limit x tends to infinity, 1 by x square plus 1 by 4 by x square plus 1. So that will go to 0 and that will go to 0. So we will get 1, and our function is will belong between 0 and 1, close 0 1. So and it is non-decreasing, and the first part will also be non-decreasing. So our option 4 is a correct option of this question. So the correct options are this and this. Hope you understood, guys. Thank you.